Hello viewers, in today's session we are going to discuss another important problem from domain and range of functions, and here we are going to find out the domain of this function f of x, that is equal to square root of sine inverse logarithm of x to the base 4, right? So here we'll see how we can find out the domain of this function, that is the square root function, and here we have inverse sine and logarithm of x to the base 4. So using the concept of inverse trigonometric functions and logarithmic function, we can find out the domain of this function. So let us start. So here the first condition for the domain of this function f of x is that this quantity which is inside this square root sign should be greater than or equal to 0. So the first condition is that sine inverse log x to the base 4, it should be greater than or equal to 0, because this entire quantity, that is sine inverse log x to the base 4, it should be positive or equal to 0. So here if this quantity is negative, then we have square root of a negative quantity, and square root of negative quantities are not defined on the set of real numbers, right? So this is the first condition. So now here we'll make use of the principal value branch of sine inverse function. So here we know that sine inverse theta, the principal value branch is given by this interval, that is minus pi by 2 to pi by 2, provided this theta belongs to the interval minus 1 to 1, right? So for theta, here we have logarithm of x to the base 4, right? So here sine inverse theta, it is greater than or equal to minus pi by 2, but less than or equal to pi by 2. So here we have minus pi by 2, here we have pi by 2, and between minus pi by 2 and pi by 2, we have 0. Now see here, if we take this theta as logarithm of x to the base 4, then this is sine inverse theta greater than or equal to 0. So to fulfill this condition, sine inverse theta must have values between this interval, that is 0 to pi by 2, right? Because sine inverse theta has to be greater than or equal to 0. So here a 0 is included, and pi by 2 is also included, because sine inverse theta cannot go beyond pi by 2, right? And here sine inverse theta cannot lie in this interval, because here we have all negative numbers, right? So now we can write sine inverse theta greater than or equal to 0, but less than or equal to pi by 2. So sine inverse theta must lie in this interval, that is 0 to pi by 2, where the endpoints are included. So now we have here 0, and here we have sine inverse. For theta we can write log x to the base 4, and here we have pi by 2, right? So now we'll take the sign of these three quantities, right? So taking the sign of these three quantities, we have sine, then we have sine inverse log of x to the base 4, and here we have sine pi by 2. Now sine 0 is 0, and sine pi by 2 is 1. And here we can use an important property of inverse trigonometric functions, that is sine of sine inverse, say x is equal to x, right? So for x, here we have log x to the base 4. So here we have log x to the base 4. So now we have reduced this inequality to this one. So now here we have to get rid of this log function, right? So what we will do, we'll raise these three quantities to the power of this base, that is 4. And remember, here 4 is greater than 1, and we know that this function, that is a log of x to the base a. Suppose we have this function where a is greater than 1, then this function is going to be an increasing function, right? So raising these three numbers to the power of 4, we have 4 raised to 0, and here we have 4 raised to a log of x to the base 4, and here we have 4 raised to 1, right? So now 4 raised to 0 is 1, and here 4 raised to log of x to the base 4 is simply x, and here 4 raised to 1 is 4. So here we have used this important formula, that is log of here we have a raised to log of x to the base a is equal to x, right? So a raised to log of x to the base a is x. So here we have, for a we have 4, and 4 raised to log of x to the base 4 is simply x. So x has the values belonging to this interval, that is 1 to 4, right? So the domain of this function is given by x belonging to this closed interval, that is 1 to 4.